These are your warm-up problems for Friday, January 8th. In the first equation we're going to be graphing. Second equation we're just going to be solving. And the third equation we're going to be solving, but in this case we're solving absolute value equations. This is lesson 5 of chapter 5, in which case we're going to be working with two standards. Our goals for today are to solve and graph absolute value inequalities. Here are some reminders. Number 1, absolute value inequalities have two answers. To solve an absolute value equality, we have to isolate the absolute value bars first. So that means we want the absolute value bars alone on one side of any inequality, whether it's less than, or equal to, or potentially it could be greater than or equal to, but these have to be alone. When we're solving for a negative, remember we need to switch the sign, or what we say, flip the switch. And then the last thing for graphing, we always want to look at the original inequality symbol so that I can determine my graph. Okay, because we're either going to graph an AND statement or an OR statement. Okay, so here's a way to remember. Remember, that kind of looks like the letter L, and this looks like the letter L, or as close as possible. So those would be less than. So I added a less than to help you know that that's going to be an AND graph. So that's going to look something like this, or like this, where you color them in. This is the opposite of the letter L, so then that's the opposite, greater, and I misspelled it greater, meaning my graph is going to look like this, or potentially this. Okay, so the and or help you understand what your graphs look like. So here are some examples. We're going to need to solve them first, and then we'll graph them second. The absolute value of 3y minus 3 is equal to 9. First thing I note, the absolute value symbol is alone all by itself. So what do I know? Whatever is this 3y minus 3 can either be 9 or it can be negative 9. So 3y minus 3 is going to be greater than 9, or 3y minus 3 is going to be, and now here, because it's negative 9, we're going to flip the switch and change it. So now I have my two inequalities. I can now use the SIC process by adding 3 to both sides of both equations. 3y then is going to be greater than 12. Over here, 3y is going to be less than negative 6. Divide both sides by 3. Y is going to either be greater than 4 or y is going to be less than negative 2. Okay, again, in my original inequality I see greater. I misspelled it on purpose. That's an OR statement, which means my graph has to go in both directions, not the same. And they're going to go away from each other. So here's negative 2. Over here is positive 4. It's an OR statement, so y has to be either greater than 4, so all the numbers larger than 4. Here it's going to be y is less than negative 2, all the numbers less than negative 2. In the next problem, I'm going to take a look again and see that my absolute value is alone on both sides of the equation. So I'm going to write that up with s minus 3 then has to either be 12, that absolute value, or it can be negative 12. So I'll write my two inequalities. S minus 3 will be less than or equal to 12, or S minus 3 will be greater than or equal to negative 12. Again, with the negative, I need to flip the switch, changing from one to the other. I will use the SIC process now, add 3 to both sides, in both equations. S is going to be less than or equal to 15. Add 3 to both sides of this equation. S is going to be greater than or equal to negative 9. Again, less than and. That means I have an and equation, I have an and graph. So S has to be greater than or equal to negative 9. Color in my circle and go to all the numbers larger than negative 9. And S is less than or equal to positive 15. So I'm going to color it in, and then I'm talking about all the numbers less than 15. So notice again, I'm talking about here a joining of two circles, which is an and type of graph. Less than, two dots that join together. I'll do one more of these where the absolute value is alone and isolated. Okay, again, I'll work with a two-step. Okay, we can see here, because now it's 6x minus 5. The absolute value of that is greater than 14. So that means 6x minus 5 is greater than or equal to 14. And then I can also talk about 6x minus 5. Okay, I got to flip the switch because now I'm talking about negative 14. Using the SIC process to solve, add 5 to both sides here. 6x is greater than or equal to 19, not 29, 19. Divide both sides by 6. X is going to be greater than or equal to 19/6, or we can say 3 1/6. Here I'm going to add 5 to both sides. 6x then is going to be less than or equal to negative 9. Divide both sides by 6. X then is going to be less than or equal to negative 9/6, which is the same thing as negative 1 3/6, which is negative 1 1/2. So then I can graph my absolute value inequality. X is larger than or equal to 3 1/6. Going in this direction, and all the values bigger than 3 or equal to 3 1/6 or larger. Then over here, we got negative 1 1/2, and now we know x is less than or equal to that. So now we're talking about all the values that are negative 1 1/2 or less. So I have a OR type of graph which matched my OR original equation. A third type of equation that you're going to see is where the absolute value symbol is not alone. You'll notice here, I'll do the one on the right. Well, actually, I'll do both. I have the absolute value of 2x plus 1 minus 3 is greater than or equal to 6. So here you'll note that the absolute value is not alone, minus 3 is with it. So when you have problems like that, we need to isolate that. So we're going to get it alone by adding 3 to both sides. Now it's the absolute value of 2x plus 1 is going to be greater than or equal to 9. So now that I have that isolated, now I'm going to form my two inequalities. 2x plus 1 is going to be greater than or equal to 9. The other one will be 2x plus 1 is going to be less than or equal to negative 9. Again, I got to flip the switch. Subtract 1 from both sides. 2x is going to be greater than or equal to 8. Divide both sides by 2. X is going to be greater than or equal to 4. Subtract 1 from both sides. 2x is going to be less than or equal to negative 10. Divide both sides by 2. X is going to be less than or equal to negative 5. So when I graph that, it'll simply have 4 on one side here, negative 5 here in the number line. X has to be larger than or equal to 4. So we're going that way. X has to be less than or equal to negative 5. We're going that way. So that's an OR type of graph, and here's great OR, here's great OR, so I know that my graph is also correct. In the next equation, I'm going to isolate the absolute value bars by subtracting 4 from both sides. Absolute value then of 3x minus 3 will be greater than or equal to 6, which generates two different inequalities. 3x minus 3 will be greater than or equal to 6. That's one of them. And then we'll have 3x minus 3 will be less than or equal to negative 6. Again, flip the switch. Using SIC, I'll add 3 to both sides. 3x will be greater than or equal to 9. Add 3 to both sides. 3x will be less than or equal to negative 3. Divide both sides by 3 in both equations. X is going to be greater than or equal to 3. Divide both sides by 3. X is going to be less than or equal to negative 1. So I can graph that. I'm going to have negative 1. For here I'm going to have positive 3. X has to be greater than or equal to 3, so that's a closed circle going this way. X has to be less than or equal to negative 1, closed circle going that way. An OR graph, that matches an OR inequality equation, or inequality I should say. So to take this concept a little bit farther and think about it differently, I gave you equations and you had to graph. Now I'm going to give you a graph and you have to write an equation. Well, if you remember back to chapter 2, in writing an absolute value equation, we have the absolute value bars, and it's always going to be x minus a middle. In word problems, a middle can be described as an average. It can also be described as a target or a goal. And then we're going to use one of 4 inequality symbols today. We're either going to be talking about less than or equal to, or we're going to be talking about greater than or equal to. And then this number out here is always going to be the distance and end point. So here's the end. The distance that the end point is from the middle. Okay, so when I look at this graph, the first thing I'm going to do is say, all right, well, the equation is going to start out with the absolute value of x minus. I look at the graph and I see 2 open circles that are connected, so I know that's an and. Because they're open, it's only going to be less than. It's not going to be less than or equal to. And now it comes to filling in those 2 blanks. Well, the middle of this particular graph is going to be right here at 4. So that goes inside the bars. And the distance from 4 to 10 is going to be 2, 4, 6. 2, 4, 6. So then that's going to go out there. So there is my absolute value inequality. The absolute value of x minus 4 is less than 6. In the next graph, again, you'll see 2 open circles, but now you see the arrows going this way, opposite, away from each other. So first of all, I know again, well, it's got to be absolute value. I'll erase to make that a little bit more space in there. And now I know that that's an OR type of graph. And because they're open circles, it's simply going to be great OR. We'll put x minus in the middle. And again, I need to find the middle of the 2 points. So the middle of negative 2 and 4 is going to be 1. So it's the absolute value of x minus 1. And then the distance from the middle to an end is going to be 1, 2, 3, 1, 2, 3. 3 on each side. So then absolute value of x minus 1 is greater than 3. You could also now solve this equation, and that would help you check to see if your graph is correct. So now that you can see a picture and write an equation, then doing word problems should be quite easy. I just need to look for those key words that tell me when to find a middle or find a range from that middle so that I can do it. I would also even suggest this. When you have word problems, see if you can draw the graph from the word problem. Okay, so let's take a look. The average annual rainfall in California for the last 100 years, that should be is 23 inches. The average is, okay? However, that annual rainfall can differ, can change by 10 inches. Okay, so if you think about that from common sense standpoint, so from 23 inches, if it can differ by 10, that means I can go out 10 more, and that would be 33 inches of rain, or I can go this way, and I can go 10 less, which is 13. So that would be a common sense way to think about it. Well, now that I have my graph, okay, I can think about it as, well, it's going to include 13 inches, so that means it's going to be a colored in circle. And it's going to include 33 inches, so it's going to be a closed circle. And because it can be anywhere in between there, that means we're talking about this amount of space on the number line. Okay, so that's easy to look at and see simply from a common sense standpoint. Well, now that I have a graph and how it looks, I can write my inequality now. Absolute value of x minus my middle, which is 23. Okay, this is an and type of graph that has circles that are colored in, less than or equal to. And then, how far apart is the edges from the middle? They are 10. So there would be your absolute value inequality. Okay, which a question might say, solve it and graph it. Well, we already did the graph, so here we just need to use SIC and come up with the two answers, which would have been anyway 33 and 13. So the final application question, okay, if a thermostat at Macy's house keeps her temperature within 3 degrees, okay, within, that's a monster word and what this is applying for this problem, a set temperature, that also is important. So if the thermostat is set at 72, what is the range of temperatures? Well, again, I can use common sense. I know that from 72, okay, I can have a range where we're within 3 degrees. That means I can be 3 degrees more than 72, which is going to be 75, or I can be 3 degrees less than 72, which is 69. There's the common sense part. Well, now that I know that, I've just created a graph. Okay, and I do know that my temperatures include the edges. They include 69 and they include 75. So I put closed circles there. So then writing my absolute value inequality is easy. Absolute value of x minus the middle, the set temperature, the goal temperature, has to be less than or equal to, because that's an and type of graph, the distance, the middle from the edges, which is 3. Again, you may be asked to then solve this, which you already have the solutions, but we would need the SIC process so that you can show us how to get 75 and 69. And then you would be asked to graph it potentially in your homework. This concludes the lesson on absolute value inequalities, which is 5.5. Your homework for this evening is on page 314, 8 through 30, and 32 through 35.